the fall 2010 final. I've listed it as practice A. We're going to start on 15. So it says x plus 2 is a factor of which of the following polynomials? So there are a lot of ways to do this. You could do long division or synthetic division. And if you get a remainder 0, then it works. Or you could graph it. And if it hits the x-axis at -2, then it is a factor. So that one's pretty easy. Does anybody want to see that? Everybody understand how those work? Okay, let's go on to the next one. So number 16, we want to solve the ln of 2x minus 3 equals -2. So if there are logs on both sides, we can drop the logs and set the insides equal to each other, but not in this case. So what do I need to do here? We need to switch it to exponential form. What is the base on the natural log? E. So e to the -2 equals 2x minus 3. So we're going to add 3. E to the -2 plus 3, and then divide by 2 is this. Now, anytime you have a logarithm problem, you always need to plug the numbers back in and make sure you're not creating negatives. You cannot plug a negative in, well, this cannot be negative. Can a logarithm equal a negative number? Can you plug in an x value and get a negative logarithm? Well, the answers to logarithms are exponents. Can exponents be negative? Yes. So we need to double check that this plugged in here does not create negative numbers. For instance, if I plugged in 0, would that be a problem? 2 times 0 is 0, minus 3 would be -3. That's a problem. If I plugged in 1, 2 times 1 would be 1, and 1 minus 3 would be -1, which doesn't exist. So as long as this is bigger than, what, 3/2 or something? Yeah, then we're okay. So we need to check. Well, so if we had 3 squared equals 9, that's log base 3 of 9 equals 2, right? Well, if this was an x, that's this number here. So if that's an x, can x be negative? Can you take a positive base and a positive or a negative exponent and create a negative number? If the base is positive, then every multiplication of it will also be positive. So there's no way to have x to the something equals a negative number if x is positive. It just can't happen. So the stuff inside the logarithm is not allowed to be negative. Now, you can have negative bases, but we don't usually because negative bases are really erratic. If you square a negative base, it's positive. If you square root a negative base, it doesn't exist. So this could technically be negative, but we never do it that way because it doesn't make any sense. At least not in a continuous model. So on a calculator, we need to check that e to the -2 plus 3 over 2 plugged in there is going to create a positive number. So if I type in e raised to the -2 on my calculator, and I add 3 to it, oops, and then divide it by 2, I get 1.56. If I multiply 1.56 by 2 and subtract 3, am I going to be okay? Yes. And the turning point here is 3/2. Right? If I set that equal to 0, add 3, divide by 2. If x equals 3/2, then the inside is going to be 0. That's kind of the root of the inside. So as long as this is bigger than 3/2, we're okay. E to the negative 2 is a positive number, right? It's 1 over e squared. So a positive number plus 3 divided by 2 has to be bigger than 3/2. So in this case, we're all right. And we can go ahead and say the answer is A. All right, next problem. So log base 2 of x squared minus log base 2 of 1.5 is 2. What should I do here? No. You can only drop the logs if you have a logarithm equals a logarithm with nothing else there. So in this case, I have 2 logarithms on one side and none on the other, so dropping the logs won't work. I need to combine them using the quotient rule. So the log base 2 of x squared over 1.5 equals 2. Now what? I need to convert to exponents. So 2, this one, raised to the second equals x squared over 1.5. So that's 4 equals x squared over 1.5. So I multiply this by 1.5, which is 6. 6 equals x squared. So I square root. X equals plus or minus the square root of 6. But this is a logarithm problem. So I need to go back in and see, do any of these create negatives inside the logarithm? So if I plug the positive square root of 6 in there, am I okay? The square root of 6 squared is 6. We're fine. Can I plug in the negative square root of 6? Negative square root of 6 squared is 6. So this one is going to be D. Did I get it right? All right. 18. Find matrix A. If given matrix A, find A inverse. So we have 2, negative 6, negative 8, and 24. How do we know if a matrix is invertible? So this is sort of like the xy portion of a 2-variable linear system, right? So it's like saying we have 2x minus 6y and 8x plus 24y. Okay? If those two lines are parallel, then the matrix is not invertible, which means the augmented matrix of the system would either be no solutions or infinite solutions, depending on what the answers were. Do you remember that? So is one of the lines a multiple of one of the other lines? Is one of the rows a multiple of one of the other rows? Can I times the top row by anything and make it equal the bottom row? If I times the top by negative 4, then I get the second row. So if I had the equation 2x minus 6y equals 4, and 8x plus 24y equals 10, this system would have no solutions. Because if I times the top by negative 4, I get negative 8x plus 24y equals negative 16. And these two equations are the same, but they have different answers. So that would be no solutions, right? Okay. Well, if I change this, actually, let's just change this one to negative 16. Now the system has infinite solutions, and in both cases, that original 2 by 2 matrix is not invertible. It can't be done. So this one I know is no solutions. It's not invertible. Now, what if it was invertible? How do I invert it? So the way we learned it was this. You just augment it with the identity, and then you do RREF. Now, you could use your calculator for that. So you could plug in this matrix, and if the answer looks like this, then whatever is there will be the inverse. Okay? Do you want an easier way to do it? Just plug this in your calculator as matrix A. So A equals 2, -6, -8, 24. And then on your calculator, do A inverse and hit enter, and it will invert it for you. Okay, but in both cases, in this one, you're going to get error. It doesn't exist. And in this version, you're going to get 1, 0, something, something, and then 0, 0. And if that is not the identity, then the matrix is non-invertible. Okay? But I would just type it into A and then do A inverse. Where's the inverse button on your calculator? You guys know where the inverse button is? It's right above the x squared button. There's an x to the -1. That's the inverse button. Okay. All right, 19. In the partial fraction decomposition of 3x over x squared minus x minus 2, the numerator of the term with the denominator x plus 1 is? So we have 3x over, does the denominator factor? X minus 2 and x plus 1. So I have two linear factors with no replication, no duplication, right? How many partial fractions will I have in this case? 2. And they're both linear. So A over x minus 2 and B over x plus 1. Now what do I need to do? I need to multiply the A partial fraction with the parts of the common denominator that it doesn't already have. A has an x minus 2, so I need to times it by x plus 1. B has an x plus 1, so I need to multiply by x minus 2. And the reason we do that, if you've forgotten, so now the entire fraction has the same common denominator. And once everything has the same common denominator, what do? We just get rid of all the denominators. If I had a big equation where everything's divided by 2, I could just drop the divided by 2 and everything on top is still equal. So we're going to get rid of all of this. So we're left with 3x equals ax plus a plus bx minus 2b. And then I just group together all of the x's and all of the constants. Now, this does not have a constant, so I'm going to put a 0 in there to remind you how it works. So ax plus bx equals 3. And then a minus 2b equals 0. So now I just go to my calculator, into my matrix, a 2 by 3. So 1, 1, 3, 1, -2, and 0. And then I need to do RREF of A. And I get the matrix 1, 0, 2, 0, 1, 1. So my A is 2 and my B is 1. So my answer is 2 over x minus 2 plus 1 over x plus 1. But the question asks, the numerator on the x plus 1 term is 1. So that would be letter C. Everybody understand that? Okay. Number 20 is really easy. Log base 16 of 4. How do we solve that if you don't already know what it is? So we do, it's actually ln 4 over the ln of 16. But if you look at this, 16 to what power is 4? 1/2. It's the square root. Or you just type it in. All right, story problems. So on the multiple choice, I'm not allowed to give any partial credit. So I just have to grade it as a multiple choice, and you either get it or you don't. So I mean, showing your work isn't really not that important on that part, because I can't grade it anyways. But on this part, if you do something, write it down, because I can go through your work and give you partial credit. If you just graph it and throw an answer up and it's wrong, I have to mark it entirely wrong. But if you show your work and I can follow through where you went, then I can give you as much credit as you did correctly. So on the multiple choice, if you miss a negative and you pick the wrong letter, it's all wrong. But on this, if you miss a negative and everything else is correct, I can give you all the credit except for that one sign. So you want to show your work on this part. Oh, this says do any 4 of the 5 problems. I'm not sure if your final will be that way. I haven't done that. Okay, a small bicycle shop produces custom frames for mountain bikes and road bikes. In order to maximize profit, they have formulated a linear program model in an attempt to determine the daily production quantities for each type of frame using the variables x. Okay. So maximize 3x plus 4y subject to the constraints. Oh. That's linear programming. We're not going to do that problem. That was not part of our core this year. Well, let's just graph it. We won't do the linear program piece. So the graph, it's got to be bigger than or equal to 0. So this is a solid line shaded up. And y has to be greater than or equal to 0. So that's also a solid line shaded to the right. I guess I got that backwards, but you understand. All right, so x plus y is less than or equal to 4. So that's going to have an x-intercept at 4 and a y-intercept at 4. Is that a solid or a dotted line? Solid line. And which direction do I shade? Plug in 0, 0. 0 plus 0 less than 4. Is that true or false? True. So we're going to shade toward 0, 0. And then 2x plus y equals 6. If you eliminate the x, you get y is less than or equal to 6. If you eliminate the y and divide by 2, you get x is less than or equal to 3. Here's the 3. Connect those two with the solid line. I'm going to shade up or down. Plug in 0, 0. Is 0 plus 0 less than 6? Yes. So this is true, which means everything in that direction is true. So that would be the shaded region. Anything in that region will satisfy all 4 equations. And then they want us to find the maximum profit of 3x plus 4y, but we didn't do linear programming. So we'll skip that part. All right. So for the next one, number 2, we have a river. We want to build a fence that looks like this. Apparently, whatever they're fencing in can't swim, so we don't need to build a fence along the river. And we have 1,200 feet of fence. And those 2 rectangles have to be identical, which means that this length and that length are the same. And then these 3 lengths are the same. And the width of the rectangle is denoted by x, which one's the width, right? There will be no fencing required along the side of the rectangles that borders the river. The width of the rectangle is denoted by X. Anybody want to take a guess at which one is the width? Oh, it shows me. There we go. So called this X. All right. So if that's X, X, X. So how are we going to figure out the area of each of these rectangles? So we could call this L, right? So the area of each rectangle is X times L. The trouble is we have no idea what L is. But I do know that I have 3 X's. So 3X plus 2L is equal to 1,200. Okay, what else do I know? What about the area of each rectangle? So the area is going to equal X times L. So is there any way to figure out L in terms of X? How big is L in terms of X? In that original equation, can we solve for L? So how would we solve for L? Subtract 3x, divide by 2. So L is 1,200 minus 3x over 2. And the reason that is, we take all of the fencing, we subtract off 3 widths, then we end up with this length here. And the length we're looking for is half of that. So 1,200 minus 3x divided by 2 represents one of these lengths. Okay? So I can plug that. I can't really plug that back into itself. Well, I guess you could. But I can plug that into the area formula. So the area is X times 1,200 minus 3x over 2. And that would be the A of X formula that expresses the total area in terms of X. Does that make sense? So that formula represents every possible fence built. Well, that was A. A says find the formula, and B asks, your favorite question, how many fences could we build like this? How many fences does this equation represent? An infinite number, supposing that you can do any small amount of fencing, right? That you don't have to stop at a particular panel or something. So the next question says, okay, if you can build an infinite number of fences, which one will create the maximum area? A circle would be, but it's got to be rectangular. Yeah. So we have the equation. How do we maximize an equation? You graph it. I wouldn't even distribute it. One way you could do it, you could distribute this through, create a quadratic, find the roots, average the 2 roots, and that will tell us where the maximum is, and then plug it in, and that will give me the maximum. Seems like a waste of my time. So what I'm going to do is just plug it into my calculator. X times 1,200 minus 3x over 2. Let's see if you guys can see this. It's not working, is it? So I push graph. Yeah, it's not on. So I don't even see it. So here's what I would do. Change my window. I don't need any negative x's, so 0. How big do you think this fence is going to be? Well, I only have 1,200 feet of fence, and x represents, they called it the width, but I think the height makes more sense. So the maximum area is probably going to be like 1,200 divided by 5, because there are 5 different lengths of fence that I'm looking at. So 1,200 divided by 5, but let's do like 400. If I go too far, that's okay. So I'm going to go from 0 to 400. What do I pick for my y values? Nothing. Zoom fit. I let the calculator figure out the y values for me. Zoom, and it's down at the bottom. Well, it's in the middle somewhere. Zoom fit. That will take my x's and choose y's that totally encompass the graph on that x, on those x possibilities. Okay? Now, I have no idea what the axes are, but I don't really care, right? I can just now do second calc maximum, and then I go to the left, enter, I go to the right, enter, so 200. Oh wait, that's the length of the fence, but it wants to know what is the maximum area. 60,000. When x is 200, the maximum enclosed area would be 60,000. Provide all necessary computations needed to determine your answer. I would draw the graph. All right. Number 3. I guess I could turn my calculator on. That might help, right? A drug is given to patients recovering from heart surgery. A dose is determined for each patient that will result in an initial concentration of the drug in the patient's bloodstream of 85 milligrams per liter. The drug is injected in the morning, and the concentration C of the drug T hours later can be modeled by the exponential decay model. C sub 0 times e to the negative kt milligrams per liter when t is bigger than or equal to 0. So all of that is a really fancy way to say PE to the negative RT, right? Now, normally, we would just do PE to the RT, and when we're done solving it, R will equal a negative number. But in their formula, they have used the negative in the formula. So if you solve it the way it's written, then your answer in the calculator will be positive, but you understand the difference, right? If you use the top formula, you'll get something like 5%, 0.005, 0.05. If you use the bottom formula, you'll get negative 0.05. So it doesn't matter which one you use. Okay, a blood sample is drawn from a patient at 5 hours, and the injection concentration is 63 milligrams per liter. Using this information and the information provided above, determine the concentration function. So y equals p to e to the negative rt. And it tells us that initially there are 85 milligrams per liter. 5 hours later there are 63. So what are we going to do? There is a way to do it that way. I wouldn't. What? Do we know any of these values? T is 5. P is the 85, the original amount. And Y would be 63. So 63 equals 85 e to the negative r times 5. How are we going to solve for r? I'm going to use logs, but I can't do that yet. I got to divide the 85 out of the way. So 63/85 equals e to the negative 5r. Now I ln both sides. And I get ln of 63 over 85 equals negative 5r ln of e. But the ln of e is 1. So I divide this by negative 5. And I have a calculator now. So ln of 63 over 85 divided by negative 5, 6%. So yeah, right. I wouldn't be too picky on that. That's so close. College professors are a little bit ornery, but I'm only slightly ornery. Okay. Number 7. When the concentration of the drug falls below 38 milligrams per liter, the drug no longer has the desired effect, and another injection must be given. Using the result from Part A, determine the time at which the concentration of the drug will be equal to 38. So what is that asking us to do? So we want to know, using the same equation, and now we know that the decrease rate is 6%. So we want to say 38 is equal to 85 e to the negative 0.06 times t. And we want to solve for t. So same idea, divide by 85, ln both sides. The ln of e cancels, and I get the ln of 38 over 85 is equal to negative 0.06 t. So we divide by negative 0.06, which is essentially the same problem we did before. We just change that. And that tells us 5 hours. Oh, wait a minute. Sorry. That doesn't make sense. Yeah, this changed to 38. Okay, how about 13.4 hours? That makes more sense. All right, number 4. A plant at which digital cameras are assembled hires new workers depending on the demand for the cameras. From past experience, it has been determined that the number n of cameras that a worker can assemble each week at a time, t weeks after being hired, can be modeled by that function. So essentially, the longer you work there, the faster you are at assembling cameras. And the function given is number of assembled cameras during a week is equal to 20t plus 5 over 1.5t plus 4. Wait, that's 15.t. That doesn't make any sense. How about 1.5t? Okay. Can we factor anything out of the top or the bottom? We can factor a 5 out of the top. 5 times 4t plus 1. What about the bottom? I could factor out a 1.5. I could factor out a 4. Well, if I pull out a 4, now you probably don't need to, but 4 times what is 1.5? Or what is 1.5 divided by 4? So 0.375 doesn't appear to be worth it. So 1.5t plus 4. I just wanted to double check to make sure that the bottom was not some incarnation of 4t plus 1. Okay, so does this have a vertical asymptote? How do you have a vertical asymptote? When a factor in the bottom does not cross out. Okay, so does the factor in the bottom cross out? No. When do you have a hole? When the factor on the bottom does cross out. Okay, when do you have a horizontal asymptote? When the bottom's bigger than the top, you have a horizontal asymptote at 0. What if the degree of the bottom and the degree of the top are the same? Then the horizontal asymptote will be whatever the first term divided by the first term is. So in this case, this is t to the first and t to the first. So if we divide those, 20t over 1.5t, the t's cancel, and 20 divided by 1.5, we have an HA at 13.3, which is probably going to be the maximum amount of cameras a person can assemble in a week, right? So the whole idea behind this problem is the longer you work there, the better you are at assembling cameras, but you're not going to go to infinity. Nobody can assemble an infinite number, so there has to be some sort of limiting capacity for this equation. And we have an HA at 13.3, which is probably going to be the maximum amount. Now, is anybody ever going to get to 13.3? So the graph will probably look something like this, and we're approaching 13.3, and somebody who works there for a year might be able to do 13.28, and somebody who works there for 10 years might be 13.29. Do you see what I'm... And then there's the guy who's been there forever, and he's exactly 13.33333, and so on. Okay. You could graph this, and you'll get, I don't know what it, so if I set the bottom equal to 0, that's negative 4 over 1.5. So I'm just going to remind you how to graph these. So negative 4 divided by 1.5. So there's an HA, or a VA at negative 2.6. So the graph probably looks something like this. Looks like that, right? So you're never going to find exactly where it is, but if you extended your x-axis way out here to like 10,000, or even you could just go to your table, eventually you're going to see that you're really, really close to 13.3. Maybe I'll do that. So if we graph this function, so 20, oh wait a minute, I need parentheses. 20x plus 5 divided by 1.5x plus 4. And let's just do the standard window. It's probably going to be sort of okay. So you can see that that's going to be limiting. If we go over here to my table, pretty quickly, maybe not so quickly, 12. If you go far enough, you'll notice that it just stops going up. We're going to have to go way out there. So that does work, but you've got to go quite a ways before you notice that it doesn't go any further. Look at that. I'm not even touching it. There is a way to jump ahead. Maybe this will stop eventually. So you can do second window, which is table set. And you could go all the way out to like 3,000, enter, and then go there. And it's gonna take a while before you get exactly as far as you want, and if it's not a nice number, it's kind of tough. But we're at 13.323, so that's a little bit difficult. Yeah, the graph should help. So letter A, what time will the number of cameras assembled in a week by a new worker be equal to 10? Well, it's equal to 10. So if you graphed it, then you would have to find what x value equals 10, and it might not be a very nice number. You know, it might be like 48.37 weeks. So the easiest way to solve this would probably be 20t plus 5 over 1.5t plus 4 equals 10. How do we solve that? Or which is essentially the same as cross multiply, right? So 20t plus 5 equals, I'm going to distribute the 10, 15t plus 40. So I'll move this over and I get 5t. Move that over and I get 35. So t equals 7, which when I was scrolling through, I actually saw the answer. So I'm going to go back into my table set, and I'm going to go back to 0. And you can even change this delta table. That changes what the table counts by. So if you want to count by 5s, or if you want to count by 1/2, you can change that. And if you go back to your table, if we go down to 7, I notice that we hit exactly 10. So in this case, the table gave you the answer you wanted. But solving it algebraically wasn't too bad. 7, what value of the number of cameras assembled each week by a new worker approach as time approaches infinity? That's the horizontal asymptote, so 13.3. If you're going to do that with your calculator, I would set your table at something like 10 billion. You know, something way, way over there. And then, all right, next problem. Number 5, a tourist agency wants to provide an air shuttle service to a resort island located offshore from their headquarters. The plane will hold 80 passengers, and they plan to sell both coach and first class tickets. To be profitable, they need the revenue from each flight to be $9,600. Market research has indicated that they can fill each flight by selling coach tickets for $100 and first class tickets for $150. All right. This is going to be a linear systems of inequalities. So, x plus y has to be less than or 80 passengers. Right? They can't hold more than 80 passengers. And then, excuse me. To be profitable, they have to make at least $9,600. So $100 times the number of coach tickets plus 150 times the number of first class tickets has to be greater than or equal to 9,600. So that would be A. That is the linear systems of equations. So if I graph that, 80, that's 80. That's this line. It's solid because it's equal to, and we're going to shade down. And then if I divide that by 100, my x is equal to 96. And then if I do 9,600 divided by 150, Oops, sorry. I get 64. So 64 and must be 96. So yes, this is an equal to. And I want to shade. So I plug in 0, 0. Is 0 plus 0 bigger than 9600? No, so this is false, which means I shade up. So the only way for this to work is in this little space right here. As long as you can fill the plane with a lot of first-class tickets, you'll be okay. The profit margin is very slim, though, which is probably true of airlines, which is true of anything where there's a ton of competition. How many airlines are there out there? A lot. And how often do airlines change hands and start up and move and all the time, which means that the profit margin has got to be really small. All right. That is it for that test.